to do is I'm going to give you some kind of information, the value of one of the trig functions, and ask you to find all of the others. Now we have found all the trig functions when I gave you an x and a y, because then we could get r and use all the ratios. What I'm telling you is that my angle is in quadrant 3, and tangent is equal to 8/5. I want to find all the other trig functions. Any ideas what I could do? There's really a couple different ways to think about it. Okay, we know cotangent automatically, don't we? Cotangent would have to be what?
5/8.
So that's an easy one. So now we just have to get the others. All right. How can I go about getting these? What's the definition of tangent? Y over x. Okay, so this is saying then my x would be what number? 5. And my y would be 8. Now there's something wrong with that though. If you're in quadrant 3, what's true about x and y? They're both negative. Now we didn't see the negative here because we know a negative divided by a negative gives us the positive. But that quadrant is telling you what has to be negative. So now I have x and y, and that means we can get r. We know r is the square root of x squared plus y squared. So we did the square root of 89. Does that reduce? No. So then we can go through the rest. Sine is y over r. So that would be negative 8 over the square root of 89. And we know we have to get the radical off the bottom, so that would be negative 8. Radical 89 over 89. Reciprocal of sine is cosecant. So I told you it's easier to flip before you move the radical, so that would be negative radical 89 over 8. Cosine is x over r, so negative 5 over radical 89. Negative 5 radical 89 over 89. And then secant is the reciprocal of cosine, so that would be negative radical 89 over 5. So if I give you the trig function, you have to figure out which variables have I just given you. Use your quadrant to figure out what's positive or negative, and then you can do it like before. Is that okay? There are other approaches for this. You could draw a triangle and use SOHCAHTOA. Your book also starts here giving you some trig identities, which are basically some formulas that work with trig functions. We will use these more later on, but I want to go ahead and start throwing some in here and there. And this is just another resource that we can use to figure some of these things out. So we know in a right triangle, this x squared plus y squared equals r squared. That's how we find r every time, right? So we can actually manipulate this to get some identities. If I went through and I divided, we know in an equation, as long as you divide everything by the same number, that's equal. So if I divided everything by r squared, we get x over r squared, y over r squared equals 1. X over r is what trig function? So that's saying cosine squared theta plus, what's y over r? Sine squared theta equals 1. This is probably the single most important identity that we will see right now. And it's really the one that carries on if you have to take calculus. Out of everything we use in trig, this is probably the thing that gets used the most often in further math classes. Sine squared theta plus cosine squared theta equals 1. It's a Pythagorean identity. There are 3 of these Pythagorean identities. This is the only one that I would ask you to use right now. So you might try, you know, on the homework, I don't think it ever specifies that you have to do a problem this way. But if I did ask you to use Pythagorean identity, this would be the one that I would ask you to use. There are a couple others that come from the same original formula. I started out dividing by r squared, but I could have divided by anything if I divided by x squared. And you get 1 plus y over x squared equals r over x squared. What is y over x? What is r over x? So 1 plus tangent squared theta equals secant squared theta is the second Pythagorean identity. How do you think I get the third one?
Divide by r squared.
So x over y is cotangent squared plus 1 equals r over y. So again, I'm giving you all 3. If you want to use them right now, you are welcome to. At this point, the only one that I would really ask you to try to remember is the first one. This cosine squared theta plus sine squared theta equals 1. Another thing that comes up in terms of some identities, we have quotient identities. So I want to know, if I took sine theta divided by cosine theta, what would that give me? What is the definition of sine? Definition of cosine. All right, from algebra, how do you divide fractions?
You multiply by the reciprocal.
So the r's cancel, and we get y divided by x, which is tangent. So sine theta divided by cosine theta is equal to tangent. If you did the reciprocals then, cosine divided by sine is the reciprocal. What's the reciprocal of tangent?
Cotangent.
So that's a couple other things we could use to help us along the way. Questions there? Let's look at couple more examples. And just practice. Again, right now, I'm gonna say find these things and I don't care how you do it. So I want to find cosine and tangent. So I'm not asking for all 6, just cosine and tangent. Given that sine is negative radical 2 over 3 and cosine is positive. So we could do it like we did the last one in terms of x, y, and r. Sine is y over r. Can r ever be negative? No. So that means your y would have to be the negative radical 2. Your r would have to be a 3. If cosine is positive, cosine is x over r. If that's positive, what kind of number does x have to be? Positive. Right, we've never really had to find x before. We always have to find r. We use that r is equal to the square root of x squared plus y squared. Another way to think of that is x squared plus y squared equals r squared. So if we plug in what we have. Negative radical 2 squared is just 2. Square root, with that we need plus and minus, but we know that since cosine is positive, we need a positive x. So my x would have to be the square root of 7. So then cosine x over r will be radical 7 over 3. Tangent y over x would be negative radical 2 over radical 7. And move the radical. So negative radical 14%. If you guys are okay with it, can I show you another way to do the same problem? And I don't care if you write it down or not. I just want to show you, I gave you all those formulas, so I thought I might show you at least one case how you might use them. In general, it seems like most people prefer the x, y, and r definition, but there's always somebody that likes using these identities. So I want to give it to you in case you're that person, and that makes more sense to you. So if I have sine, and I need cosine, we could use the identity cosine squared theta plus sine squared theta equals 1. Okay, if you just want to solve an algebra problem. We don't know cosine. Sine is negative radical 2 over 3. We have to square that. So negative radical 2 squared. So negative radical 2 times negative radical 2 is positive 2. 3 squared is 9. Subtract that over, so 1 minus 2 ninths is 7 ninths. To get rid of a square, we square root plus or minus, but I said cosine is greater than 0, so we'll take the positive. We don't know the square root of 7, but the square root of 9 is 3. And then if you have sine and cosine, you can use that sine divided by cosine equals tangent. So it's a negative radical 2 over 3 divided by radical 7 over 3. You can't just put that into your calculator because of the radicals, but to divide fractions, we flip and multiply. So then the 3's cancel. We get negative radical 2 over radical 7. And then again, move your radical off the bottom. So multiply by radical 7. This is probably a little bit longer, but sometimes people that are really algebra minded like it because it's just plugging something into a formula and working it out. I don't care as long as you can get to the final answer. That's fine. What do you guys prefer? Does anybody like this better? You guys like X, Y, and R? Okay, then that's probably what I'll do on future examples. Do we need more examples like this? Okay. So what I'm going to do is give you guys some time to work, and then towards the end we might kind of recap some of the things that we were learning last week. So we went up through 58 Friday, so then we can add in this new chunk and have some time to work on that.